This particular video, we are going to discuss about current voltage divisions. When the current divides, when the voltage divides, how to divide the current, how to divide the voltage, and how to find the equivalent resistance of a network. These things we will discuss. And the objectives are saying which components are in series, which components are in parallel, voltage division, current division, and what are the various voltage sources and current sources, and how to calculate the equivalent resistance. Those things we will try understanding in this particular video. So first thing is, see these two components, series and parallel combination. In this particular circuit, resistor 1 and resistor another resistor 1 ohm resistor are in series with each other. So it's just like this is one resistor whose value is 1 ohm, and this is another resistor whose value is also 1 ohm. Right? They are connected to a power supply of 10 volts. So this is what is the schematic symbol of 10 volts power supply. Then you see the current flowing through this entire combination is 5 amperes. So if you apply KVL in this particular mesh, so let us assume the current in this is I. So from A to B, so this is 1 into I plus 1 into I. So then minus 2 plus, then minus 2 plus is minus 10 volts is equals to 0. Okay, so 2I is equal to 10, so I is equals to 5 amperes. So it is very clear that the current flowing through this entire combination is 5 amperes. If two components are in series with each other like this, okay, current will not get divided. The current that is flowing through this will be as similar as the same amount of current. Okay, same amount of current flows through both the resistors, but you see the voltage at this particular point with respect to this is 10 volts. The voltage at this particular point with respect to this is 5 volts. The voltage gets divided, but the current will not get divided. So point to be understood is voltage division is possible in series circuits. Current division is not possible in series circuits, right? If two components are in series, current will not get divided, but voltage gets divided. Now, to find the equivalent resistance, we use R equivalent is equal to R1 plus R2. So this resistor is in series with this resistor. The equivalent value is 2 ohms. So 1 plus 1 is 2 ohms. We simply add them. Then now these two are in parallel with you. Wherever this is starting, this is also starting. See in this particular thing. So this first terminal of this is also connected to positive. This first terminal is also connected to positive, and both second terminals are connected to negative. So you can say these two are in parallel with each other. In parallel circuits, if two components are in parallel with each other, we use the formula R1 into R2 by R1 plus R2. That is R equivalent. If this is R1 and this is R2, the value of this is 10 ohms and this is 10 ohms. 10 into 10 by 10 plus 10, that is 5 ohms. So like this, the voltage, the equivalent resistance can be calculated. And one interesting thing is, if components are in parallel, current gets divided. So this 2 amperes, 1 ampere current will flow through this, 1 ampere, remaining 1 ampere current will flow through this, right? So here the values of the resistors are same, so the current that is flowing through both the branches is also same. 1 plus 1 is 2 amperes. So but the voltage, both are connected to 10 volts. The voltage drop across the first 10 ohm resistor and the second 10 ohm resistor, both are same. So to remember, so in parallel, if two components are in parallel with each other, the voltage will not get divided. Voltage will not be divided, whereas current will be divided. Current will be divided. Right? Current division is possible, voltage division is not possible. Now coming to the next last combination, where now these two resistors are in parallel with each other. This whole combination is in series with this. So if you see 20 and 30 are in parallel, the equivalent resistance is going to be 20 into 10 by 20 plus 20 plus 10. So that is 200 by 200 by 30. 200 by 30. So that is what is the equivalent resistance, right? That is 6.7, and this whole combination is in series with this. So we simply add R3 value. So we'll get 16.7 ohms as the equivalent resistance. Equivalent resistance. Now from this particular network, you have to observe two things. Okay, so this is not completely series, not completely parallel. Now if I replace this entire thing, with one single resistor like this, through that 600 milliamperes of current will flow through. Okay, so voltage division also will happen, and current division also will happen in this. So this entire thing, the 600 milliampere current will flow through this, part of that will flow through this, and part of that will flow through this. In whichever branch in whichever branch the resistance is more, the current through that particular branch will be less. In whichever branch the resistance is less, the current through that particular branch will be more. Okay, so but these two are in parallel with each other, so the voltage drop will across these two will be same. The entire applied voltage gets divided into two parts. One is across this 10 ohms, the other one is across the combination, that is 4 volts. 4 volts. So with respect to this, the voltage drop, with respect to 0 volts, the voltage drop at this particular point is 4 volts. The voltage at this particular point is the 10 volts, and across this it is going to be 6 volts. 6 volts. So in this type of circuits, voltage division also will happen, and current division also will happen, right? So you can increase this current or decrease this current by increasing or decreasing the resistance value in this particular path. If you increase the resistance value, current decreases, and if you decrease the resistance value, the current increases. So like that, you can design a circuit according to your requirement, right? So there are different sources available. So there are direct sources, alternating current sources, independent and dependent sources, and dependent sources. This is a constant voltage source, a DC voltage source, independent voltage source, and this is constant current source or independent current source. So there are various types of dependent sources are there. This is the schematic symbol of dependent sources: voltage dependent voltage source, current dependent voltage source, voltage dependent current source, current dependent current source. And these are the schematic symbols of AC voltage source and AC current source. And we try understanding the procedure of calculating the equivalent resistance for this network in the next video. Thank you.